Writing real-world equations and expressions. I can explain what a variable represents. I can write algebraic expressions to represent real-world and mathematical situations. I can write and solve one-step equations that represent real-world and mathematical situations. Steps to writing an equation from real-world problems. So we're going to underline the important information from the problem, define the variable, write the equation, solve the equation, and write the answer with the correct label. Avery wants to go eat pizza with her friends. Each pizza costs $7.50. How many pizzas can be bought if they have a total of $42.50? So I'm going to underline the important information. So what's important here? Each pizza costs $7.50. And then they have a total of $42.50. And they want to know how many pizzas can be bought. So let's define the variable as P equals pizzas. When you define a variable, you always need to write out what it is. So when I write the equation, I have to figure out the relationship between what's important. So each pizza costs $7.50. So that would be $7.50 times pizzas, because remember, when you put a variable next to the 750, that means multiplication or any number. And that is going to equal my total. So solution, I need to start with my equation. I'm going to solve this equation and isolate the variable p. In other words, p needs to be on one side by itself. So I have to undo what's being done to p. And it says 750 times p, so the opposite of that is division. Whatever I do to one side, I do to the other. 750 divided by 750 is 1, so that leaves me with p on the left side. Bring my equal sign down, and I get 5.67 pizzas. Well, can I have 5.67 pizzas? No, so how many pizzas can I actually buy for $42.50? I can buy 5 pizzas. Riley and James have a reading assignment for school. Riley has read 75 pages, and together they have read 200 pages. How many pages has James read? So, 75 pages read is important. Together, they have read 200 pages. We want to know how many pages has James read. So let's think about this. Our variable, we can write J equals, let's say, pages James read. So together they have to read 200 pages. Right now, Riley has read 75 pages. I'm going to add what James has read, and that needs to equal 200. So that is our equation. Now we need the solution. So just like we learned before, I need to get the variable by itself. On one side, I'm going to do opposite operation. That's a positive 75, so the opposite would be subtracting 75. That is 0. Bring down the J, equal sign, and then 200 minus 175 is 125. So James has read 125 pages. Kylie and her friends are going to a carnival. To enter the carnival, they must pay $10. Each ride at the carnival is $3. Write an expression to represent the total cost in dollars to go to the carnival and ride X rides. So, important information: to enter the carnival, it's $10. Each ride at the carnival, so the rides at the carnival, is $3. And we're writing an expression to represent the total cost to go to the carnival. And X equals rides. So they already defined the variable for us here. So what do we have? We start out with, if we go to a carnival and we walk in, we have to pay $10. So we start with that $10. And then we have to add the price of the rides, which is $3. But that's per ride. And the per ride is 3 times X, because that's how I'm going to figure out how much the rides are going to cost. Because if I ride 5 rides, that's $15, which would be 3 times 5. So my expression is 10 plus 3x. Okay, your turn. You try it.